The math notes for section 213 are on forms of quadratics. There are three main forms of quadratics: standard form, factored form, and graphing form. Study the examples below. Assume that a is not equal to 0, because if a is equal to 0, it's not a quadratic, and that the meaning of a, b, and c are different for each form below. The first form is standard form. So standard form is f of x equals ax squared plus bx plus c, where the y-intercept is 0c. Because if we plugged in 0 for x, we would just be left with c. The next form is factored form, where you can pull out an a, or common factor, from the whole quadratic, and then you get x plus b, x plus c, where the intercepts, x-intercepts, are negative b0 and negative c0. The third form is graphing form. This is one we've just started to learn about. So we have an a outside the parenthesis. That's our stretch, our compress, or tells us whether our parabola will open up or down. X minus h to the second power plus k, where the vertex is hk. Similarly, there are three forms of a single variable quadratic equation. So if we were to plug in 0 for f of x or y, how we could solve. The first one is standard form. This is pretty much the same as standard form of graphing. It's ax squared plus bx plus c equals 0. The second form is factored form. Any quadratic written in the form a times the quantity of x plus b, x plus c equals 0. And the third form is the perfect square form. So this is how we get it into graphing form. So we can ax minus b to the second power is a perfect square, and then it's going to be equal to c squared. And then to solve, we could use the square root property to help us solve. Solutions to quadratic equations can be written in exact form or radical form, where we leave it as a radical, so negative 3 plus square root of 5 divided by 2, negative 3 minus the square root of 5 divided by 2. Or we can write the solutions in approximate decimal form. So find the square root of 5